In today's session, we will cover what is data modeling, what is relationship is all about, and how to define or create relationship between tables. Previously, we have covered how to connect to various data sets using Power BI desktop, and also right. So how to perform data transformation using Power Query Editor. Now we will see what exactly data model and why we need it, and then let's see how to create a relationship between tables. So that's what couple of participants they asked me this question. They used to ask me, right? The questions like, do I need to understand data model? Is it mandatory? Yes, it is important understanding the data modeling because it is crucial in developing anything within Power BI. This is a very fundamental thing in Power BI. But it's vital that you master this because it can make or break your analytics or calculations later. Without creating the relationship, without creating the proper relationship between the tables, you cannot perform or you cannot generate accurate reports. Your reports will not show the accurate results. So today we will start with understanding what is data model and why data model, what is the necessity of data model, and the different types of cardinality. Followed by this will help you to understand and the concepts of data warehousing. What is data warehousing and data lake, star and snowflake schema. As part of star and snowflake schema, we'll discuss about what is dimension, what is fact tables, and also we'll discuss about the active and inactive relationship. Let me see if I can cover these topics in today's session. Otherwise, we'll continue these topics in the subsequent sessions. So what is a data model? Data model is like a blueprint. It is something like the architect's blueprint, right? Blueprint. The data architect, so he is the one responsible for converting all the data involved in business process into database. In short, data model, as part of data model, we create the relationship between the tables. Okay. So having a solid data model design in place, we can make sure that our query performance are much better, and also we can save the space on the hard disk. Okay, so in order to by eliminating the redundancy in the data, right, we can improve the query performance by having the solid data model design. There are three types of data model. One is the conceptual data model, and the next one is the logical data model, and the last one is the physical data model. The conceptual data model is an abstract data model. It is a preliminary step. As part of the data model, we do it. Okay, so wherein we define what entities the system or the database should contain. So as part of this, we identify the essential entities, nothing but the tables, and also we identify the high-level business relationship between entities. Let's say you have a grocery store. You need to represent the business facts that is part of your data model. For example, a customer places an order, and products appear on your orders, and finally, right, and also the products falls under categories, and the customers orders products across categories, across stores. So with this, you are able to understand the big picture. Okay, so what are the entities, essential entities that are involved as part of the data model, as part of the conceptual data model? Here we don't define all the attributes, which is nothing but the column names as part of each entities. So these are all the business facts that needs to be included as part of your grocery store data model design. Now the question is, who is responsible to create the conceptual data model? It is the responsibility of the business stakeholders and data architects. As part of the detailed requirements phase in the business intelligence life cycle, right, project life cycle, we capture all this information by interacting with the various key stakeholders within the organization. The next one is the logical data model. It is an extension of the conceptual model. Okay, the data architect, they move from the big picture of the conceptual model to the next phase, like the logical data model. So here we look at the detailed structure of the database. For example, instead of saying just the entity alone, right? So we describe the properties or characteristics of each and every entities. In the case of customers table, we have the customer key and first name, last name, and order fact. What are the columns that are required, right, in order to create reports, right? So different stakeholders within the same subject area. For example, you have something called order fact subject area. So different users need different reports, right? And the store manager need the daily sales report by products, by stores, right? So in that case, right, so, and again the KPIs, what are the KPIs that are required by the senior management, other stakeholders. Okay, as part of the in simple term, in logical data model, we define all the attributes like the category key, product name, cost price for each entity that we identified as part of the conceptual data model. And also the business rules, right? So not only we define the structure or we add the attributes for each table, and also we define the relationship and the business rules. So what is relationship here? So it is nothing but the cardinality. Customer places order, right? So customer place 0 or more order. Sometimes customers may not place the order, right? So let's say in my database I have 1,000 customers. Not necessarily all the 1,000 customers, all the customers should order it this month, right? So some customers they may not order it, some customer they may order it. Hence the cardinality or the relationship here is the customer place 0 or more order. And the order, when it comes to order table, order is placed by one or more customers, and the products is placed by one or more customers, right? And these are the relationship we define it. And if you look at this, we use something called crow's feet. So as part of entity relationship diagram or model, right? So what we do is we create all the entities, and then once we identify the business rule and relationship between the entities, what we do is we use something called Erwin data model tool. Okay, we have something Erwin tool. Using the tool, we create all the tables, everything, and then we define the relationship. So here we use different notations. So this is called crow's feet. Okay, this one is right, the greater than hyphen, right? This is called crow's feet, and just on top of this crow's feet, you will see the 0 circle. That means 0 or more. A customer can place 0 or more orders. So here, right, say a product, yeah, an order can have. So this represents one to many. An order can have one product or more than one product. Yeah, an order cannot have 0 product, isn't it? So in that case, you need to use this notation. Here, this is called one-to-one relationship. One-to-one relationship. A company can have only one CO. A CO can have only one company. Okay, but there are cases a CO can have more than one company also. But in majority of the cases, the CO can have only one office, and office can have only one CO. And the next one is 0, 1. Okay, and 0 or 1 relationship. So in this case, you can order product. A customer can order product, or a customer, right? So a company can provide no service, or they can provide only one service. Okay, so these are the notations that they use it to define the relationship between the tables. Relationship is also called as a cardinality. When it comes to data model design, we call the cardinality as relationship. There are two different meanings for cardinality. When it comes to data modeling design, cardinality is nothing but the degree of relationship between or the type of the relationship between the tables. This is the typical data modeling process. We normally go through while building a data model. So we identify all the entities, conceptual model, logical model, and the last one is the physical model. In the case of physical model, what we do is, here it is not there. Okay, the physical model, we define the data type and width for each and every column. That is what we do it as part of the physical data model. Okay, so you have conceptual data model, which will capture the high level relationship between the entities, and as part of the logical data model, we describe all the attributes that are part of each and every entity. In physical data model, that is where, right? So we what we do is, as part of the physical data model, we define the data type for each and every column and the width of the columns. So now the question is, why should I use a data model? Is it mandatory to use data model? Yes, when it comes to Power BI, you have to do the data model design. As I told you, in short, data modeling is nothing but defining the relationship between the tables. But without defining the relationship, when it comes to Power BI, you cannot filter the tables. Okay, I just show you with one example in Power BI desktop. Look here, I already imported. One second. I have two tables now, calendar and sales W04. Let's say I want to, instead of table, better we'll use all the time, it is boring using table only. I'll just use the bar chart, clustered bar chart. I want to say quarter by sales. I want to know the quarter wise sales or the unit sold. Or let's say the profitability, something like that. Instead of quarter, I just choose month is good. Here, there is no relationship exists between the tables. Hence, it shows for all the months, it shows the same. In this case, we have chosen the profit, right? All the months, the profit is same here. Look here. So, 139K. All the months, it shows the same aggregated, summarized value, right? So, we don't. So, there is something wrong here. That means the date, right? So date is not filtered correctly. So what I do is I create a relationship between this and this calendar table. I have something called date column. I just link this with order date column. So now we created a relationship. How do you make sure that you have there is a relationship exists between the tables? This line, okay, this line. So once you drag and drop the column, right? So the common column between these two tables are date and order date. In this case, okay, if you hover the cursor on top of this link, you can see the date on the left side table and order date on the right. Left side table, right? Order date, and right side date table, date column. Both of them got highlighted. So on this side, you can see one. That means this is a one side and this is the many side, one to many relationship. Now we created a relationship between these two tables. Let's go back to the report canvas and see. Yes, it got filtered properly. The filtering has happened correctly. Okay, what I do is I just create a chord visual. This is called chord visual. I just select this one. And if I select profit here once again. Sorry, I should have selected this visual. And yeah, I just select this one. 1.39M. So this is the total profit. This is the total profit. I'm using the table visual here. The same value is displayed here. The same value is displayed here. Here, if I select month here, Instead of month number, I just select month prefix, and if I move this up, so we can see that automatically Power BI desktop filters this aggregated value. When I simply dragged and dropped the profit value here, like in card visual, it was showing me just 13 lakh 97 something, right? But the moment when I dragged and dropped this categorical variable here, so the month prefix is also categorical variable. It has text value in it. So for each month, what is the total sales? What is the sum of sales for April month? What is sum of sales for August month? It shows the summarized value for each month automatically. The moment when I drag and drop the month prefix here, it automatically filters the profit. This is the beauty of Power BI. But can we do it in Excel? Let's say you have some number 1.39, you do some kind of sum, and then when you drag and drop it to somewhere, right? So will it does the filtering automatically? It is not possible. So that's the beauty of the Power BI desktop. This is possible because of the relationship. If I delete the relationship between these two tables, it is not happening. Look here, the same value is repeated multiple times. Here also the same value repeated. The overall profit, right? It is not doing the filtering. In order for the date table to filter, so here month, right? The month prefix to filter the profitability, you need to have the relationship between the tables. So now you understood with this simple example why data model is required. Right? So without relationship, we cannot filter data across tables. Not only one table, if you are using more than one table, and if you want to filter it across the tables, you need to have the relationship. Okay. So in the case of Power BI, the relationship is nothing but filtering, the ability to slice and dice a table by another table. For example, this is my country table, this is my sales table. Once you create the relationship between these two tables based on the common column. What is the common column between these two tables? Country ID and country ID. So what happens? Automatically in the first record, US, United States, right? You are filtering this. Let's say this is my dimension table. This is my fact table. Dimension table is also, it's nothing but a lookup table. This is my transaction table. Okay. So here you will have only unique values will be there. Unique country ID will be there. You cannot have the duplicate values here. So when you create the relationship between these two tables using the common column country ID, what it does is automatically it filters that. So US, United States. So when you use the country table filters this table. So in this case, what happens is it filters the associated country IDs from this sales table. So in this case, the first record has United States. All the associated records in the sales table got filtered automatically. And the next record, AU, Australia, the Australia related records got filtered automatically in this table. So that is what I have shown you in my Power BI desktop, isn't it? So here instead of country ID country, you have something like quarter ID, quarter name, something like that, right? So in that case, it does the filtering automatically if you have the relationship between the tables. Next, we will quickly understand what is data warehouse is all about, because if you say you are a Power BI developer, right? So Power BI, the BI stands for business intelligence. Under the business intelligence, right? The data warehousing concept falls under that one. You should be knowing what is a data warehouse is all about. Data warehouse is nothing but a centralized repository wherein we store the integrated historical data in this data warehouse. And the historical data in the sense, right, it might be 2 years or 3 years or 5 years. It depends on the type of the industry that you work. For example, in the case of banking, they store huge volume of data, and there are some companies, right? They store 10 years data and 15 years of data. It depends on the requirement, right? Business requirement. They determine the number of years of data that they house it in the data warehouse. The data warehouse is a concept. Okay, so we integrate a different source system data, and we perform the data transformation. We combine all the data and we clean the data and we apply the business rule and we pre-process the data and we store the clean data in the data warehouse so that the report users can consume the readily available pre-processed data in no time, right? So in no time. And it is also non-volatile. Data warehouse is non-volatile. What do you mean by non-volatile? Once you store the data in your data warehouse, it will not undergo any changes. Okay, if you perform any update or delete operation on this data warehouse tables, it is a very expensive operation, be it the relational database, the operational database, or data warehouse. The delete and update operations are the expensive process, isn't it? It consumes a lot of resources like memory, CPU, IO. It involves a lot of IO and all, right? So to overcome that, so as part of data warehouse, we make sure that we don't perform any update or deletion. For example, you have a dimension table, customer dimension table. A customer, last year he was living in some place in USA, and recently he moved to East Coast. From West Coast to East Coast he moved, and his address got changed. So what we do is, in the case of data warehouse, we don't update the customer's new address in his in the customers table. If you update the customer, when you take a Walmart, all the customers, right? So the millions and millions of customers are there. And even when you take the banking, right? So bank customers, 25 million customer base for Citibank, and even when it comes to telecom providers like Airtel and all, right? So they have millions and millions of customers. A lot of customers, at least 0.3 million, 0.1 million customers, they migrate one place to another place. In that case, if you start update, and again this data warehouse has, let's say, 5-year or 10-year data in it, you have petabytes and above volume of data in it, or at least terabytes and above volume of data are there in this data warehouse. If you update, what will happen? It will cause performance bottleneck. Okay, hence we avoid updating the customers. So instead of updating the customer new address, we simply insert the customer's new address so that you will get to know at any point in time what is previously where he lived and currently where he is migrated. So you will get to know these two information since they are storing the customer's history here. And similarly, when it comes to product pricing, right? So not all the products prices are static. The product prices are very dynamic nowadays, because in order to sustain the momentum, we keep changing the prices because of the market dynamics. So in that case, the pricing will vary from time to time for products. So in that case, later point in time, if you want to do some kind of analysis, right? So by increasing the price or decreasing the price, or by changing the prices with a different thing, right? A different slab. So what is the margin? How much margin? What is the revenue, right? So that if you want to perform those kind of analysis, you want to have the historical data. And in simple term, we are not going to modify the data, right? In the worst case, right, rarely we do some kind of updation, but in general we don't do any updation. But still there will be the updation will be not at the full blown level. Okay, we just do the mild updation only. And also it is called time variant. Data warehouse is also called as a time variant, because we retrieve data from 3 months, 6 months, 12 months, even older data from the data warehouse to perform year-on-year analysis, sales performance, quarter-on-quarter, month-on-month, even week-on-week sales analysis also we do it. So in that case, you need to have the history data in here. With the historical data, right, so you can do all kind of time-based or time intelligence related analysis, you can do it. So in simple term, data warehouse is nothing but it's an integrated historical non-volatile and time variant data it will have in it. But there, so now the question is, what is the difference between the operational data system, right? So the OLTP, online transaction processing. For example, you are ordering a product in Amazon, so that data will go and store in the operational online transaction processing. Okay, so that is where the data will get stored. In the case of the customer's orders, it will get stored in a database called online transaction processing. That is where the data will get stored, the customer's orders, because in the case of online transaction processing, we store only limited amount of data. We don't store the history. For example, a customer changes the location, or the customer places an order and he is cancelling it, or he wants to modify the order whatever he placed it, right? The insert, update, delete, everything is possible on the OLTP system, because we are not storing the historical data there. We store the recent data only. We don't store 5 years or years and years of data. We don't store it. If you store huge volume of data, what will happen is, for example, you want to order one product. To get the price from the price table, product table, it take a lot of time if you store huge volume of data, right? So in the case of to suit to the OLTP system related requirement, they keep the data as minimal as possible in the OLTP system. But there are some cases, yes, you need to store huge volume of data. Again, now we have Hadoop. Okay, with Hadoop you can you can do all the things. Okay, you can distribute the data across the nodes. You can do parallel processing. Everything is possible. But in general, OLTP system is meant for the CRUD operations, right? So you update, delete, and so those kind of operations it involves. If we want to insert any data, if you want to update any data, it should be faster. If you have a historical huge volume of data, it will be very slow. But when it comes to data warehouse, we store historical data. This is meant for analytics. But again, in the case of data warehouse, also we do some kind of near real-time analytics. That is a different thing altogether. We'll discuss that later point in time. Next one is data lake. So most of you might have heard about this term, data lake. This term is gaining a lot of popularity, right? So the Azure Data Lake, Microsoft Azure Data Lake also, few of my students, who got placed with the other companies, right? I came to know from them that, they are using Azure Data Lake. Even in the AWS, they are using Data Lake to store all the raw data. Irrespective of the type of the source system, you store all the raw data in the centralized place, especially in data lake. So the data lake, you store all the raw data for all the heterogeneous source system. Okay, but the difference is, when it comes to data warehouse, while you extract the data from the source system, you perform data transformation and then you load the data into the data warehouse. But when it comes to data lakes, it is kind of a ELT. We extract the data from the source system and then we load the data into your data lake. We are not going to do any transformation between the source and data lake. The advantage of this one is, you just imagine in the case of data warehouse, while you extract the data from your source system, right? So on top, while you extract the data, you are reading the data. While reading it, if you apply some kind of aggregation, what will happen? It will add additional burden to your source system. The source system, let's say this is my OLTP system. Here I store a minimal amount of data, or even in the case of Amazon, other customers, right? So even their volume of the products, right? They listed close to billion records there. Right? So they store already the volume of the data is very high, and number of compared to data warehouse it is less, but the concurrent users, right, across the globe, many users, customers, they'll be accessing it simultaneously. Already this OLTP system is burdened with right. So because of many people are accessing this one, right? already it is burdened with a lot of IOs and other things, and some customers they are ordering it, some customers they are modifying their order, they are cancelling it, and they are raising a request for return. So in that case, already it is it is overburdened. On top, just because you want to perform analytics, you extract the data, and if you apply your aggregation or any cleaning on this source system data, it will slow down the source system performance. Considering the source system performance, we don't want to disturb the source system. Simply read the data, extract the data, and load it in my centralized storage. In this case, it's a data lake, so that any people, right? So not only the data warehouse reporting users, even other users also. Sometimes you don't have to do data transformation also, right? Sometimes for example, summary data and all, right? Daily summary sales performance. In that case, daily sales report and all, you don't have to do a lot of transformation. If the data is the raw data itself, if they can consume it, they can consume it. Right? There are some applications doesn't require a lot of the transformation. In that case, they can directly consume the data from this centralized data lake. Okay, so ELT, we call it ELT, extract, load and transform. Once you load it, your data is available here, the mirror of this one, right? And then you can do transformation, and then you can store it to data warehouse, or you can source this data to other applications that require these raw data. So that is the difference between these two at a high level. So now the question is, okay, when I have an option of data lake, do I really need to have data warehouse? Yes, still you need to have data warehouse. Having these two things, right? Data lake and data warehouse, it complements each other. Okay. So you need to have this one. For example, a machine learning model or deep learning model, right? So in the Azure data lake, you can store any type of data, structured, unstructured, semi-structured, quasi-structured, any type of data, you can store it here. So that the data model, the machine learning applications can come and pick up the raw data, and then you can do you can train the model, train the model there, and the reporting users can come and consume it. But for analytic purpose, still you need to have the data warehouse, because in the data warehouse we design the data using a technique called dimensional modeling. We have something called dimensional modeling. Data. So some people they call it a star schema, snowflake schema. When it comes to data warehouse, we call either star schema or snowflake schema, or some people they call it as a dimensional data modeling. So there are two types of dimensional data modeling we can do. One is star schema, other one is snowflake schema. So as you can see here, so in the middle of this one, right, we have the table, fact table. It is a transactional. It is kind of a transactional data it will have in it, right? So the fact table is surrounded by multiple dimensions. Since the fact table is surrounded by multiple dimensions, it looks like a star. Hence, most of them they call it as we call this as a star schema. The idea of this star schema is to keep all the numeric values in a separate table called fact table, and put all descriptive information into other table called dimension tables. Okay, so there are cases, right? You will have more than one fact table also, but compared to the number of dimension tables, the fact tables are less. See, the dimension tables are also called as the lookup table. The dimension table also called as a lookup table. So so now the question is, what is the advantage of having the dimension tables? So compared to the fact table, the dimension table will have less number of data. Okay, and the fact table will have the combination of all these dimensions key values here. For example, you have a customer key. So in the case of customer dimension, the customer key should have a unique value. It should not have any missing value, or it should not have any null, and it should have a unique value. For every customer, only one record should be there. There should not be any duplication. Similarly, product table and category table and other dimension tables, we need to have only one record in it. Okay, there is something called slowly changing dimension. I'm not going to talk about this now. At this moment, you just understand each dimension table should have only one unique key. It should not have any duplicate values. You can also have the composite primary key, but it should be unique. Okay, the dimension table should have unique values, whereas the fact table can have duplicate values of your customers or products, because a single customer can order multiple times, and in each order multiple products can be there, right? A customer can order multiple products in a single order, and a product can be sold across various stores across the geography, and the products can also be sold across categories. But in the case of order fact table, you will have duplicates for customer key also. But the fact table will have the combination of all the dimension tables key values, the keys, and along with that it will have the facts. What do you mean by fact? Numeric value, units sold, gross profit, gross revenue, and cost of goods sold. So these are all numeric variable, quantitative variable, right? Since we call them measures, facts or measures. So fact table will consist of the combination of the key columns from all the surrounding dimension tables, and also it will have the measures in it. So with these measures, right, we can, so these measures will capture all the KPI related requirements. Okay. So the dimension tables are also called as a lookup table. Okay. The next one is the snowflake schema. Look here, I just go back here. The snowflake schema is slightly different from star schema. It is just an extension to the star schema, meaning if you see here that the dimension table, the product dimension table here, right? Here, this product dimension table is split into 3 tables to represent the 3 levels of the hierarchy: the product, category, and subcategory. These 2 tables, these 2 dimensions have no direct relationship with the fact table. In general, when it comes to star schema, all the dimension tables will get connected or directly linked up with your fact table directly. But here there is some kind of hierarchy here, right? Supposing you want to summarize by product data for sales, right? This would require joining the fact tables to each level of the product hierarchy. Category wise total sales, and subcategory wise total sales, right? So in that case, what will happen is you need to join the right. So you need to join the fact table to each level of the product hierarchy. Okay, so that is the one thing. But the advantage of the snowflake schema is it consumes lesser storage, and it is easier to implement a dimension, right? In this case. But due to the multiple tables, right, the query performance will get reduced. You cannot expect the faster response. So in general, what we do is we go by star schema. Even if you land up with a situation something like this, we do some kind of denormalization. We combine everything into a single table, so that you don't have to, so that it doesn't require joining multiple tables. This way we can make sure that the query performance is better. So now we will understand. So far we understood, right? So I discussed about relationship. Relationship is nothing but filtering when it comes to Power BI. So the different types of relationships are there. The one is the one-to-one, and one-to-many, many-to-one, and the last one is many-to-many relationship. The example for one-to-one is a CEO can have only one office, a office can have only one CEO, and one-to-many is a customer can order more than one product, a product can be purchased by many customers, and many-to-one is right. So many employees, right? Many employees can work on a single project, and many to many Many to many is something like customers and product. A customer can order multiple product. A product can be purchased by multiple customers. Single product can be purchased by multiple customers. A single customer can purchase multiple products. A single employee can work on multiple projects. A project can have multiple employees in it. These are the examples for many to many relationship. But when it comes to many relationship, it requires some kind of treatment. You cannot implement it as it is. But when it comes to real world scenario, we will end up with many to many relationship often. There are some techniques are available using which we can overcome this many to many relationship issues. Okay, we'll discuss this later, don't worry. In detail we'll discuss it later. Okay, fine. So what is the time now? It is good. We are still have sufficient amount of time. And okay, next we'll see active and inactive relationship. So what is active and inactive relationship? This is very specific to Power BI. It is nowhere related to the database management system related data modeling. When it comes to Power BI, there are two types of relationship at a high level. Okay, active and inactive relationship. So what is active relation? Active relation propagates filters to other tables, whereas inactive relationship does not pass filtering to other tables. Okay, the inactive relationship doesn't do anything by itself. It requires some kind of treatment. Okay, fine. So we will see with an example what exactly active and inactive relationship in Power BI. I just close this one. This is a small one. I'll open another